Here we should remember a mantra, that is all sine, tan, cos. Okay. The mantra is add sugar to coffee. Okay. Please remember this mantra. Admin, in the first quadrant, all of the trigonometric function will be positive. Okay. So add. Here in the second quadrant, the sine and the reciprocal of sine, that means cosine, will be positive and rest will be negative. Okay. So for sine we write sugar, and in the third quadrant only tan and its reciprocal will be positive and rest will be negative. Okay. That means tan and quad will be positive. And in the fourth quadrant, so here we for tan we write 2, and here cos and its reciprocal, that is sec, will be positive and rest will be negative. So for cos we write coffee. So this mantra should be remembered, and you can remember this as all sine tan cos. Okay. Hi, welcome back to our channel Avana Study Center. Today we will discuss about the trigonometric function, the chapter number 3 of class 11. This is most vital class, most vital chapter for your upcoming board exam or JEE mains advanced or WBJEE. Okay, so let's start our class. Firstly, we are going to know about the trigonometry. What is trigonometry? Actually, trigonometry is the measure of angle of a three-side shape, that means triangle. Okay, you have previously learned about the trigonometric ratio of acute angle with respect to the right angle triangle. In previous class, that means in class 10, we have known that the trigonometric ratio like sine, tan, cos, cosec, sec, cot, etc. And we have solved various problems like height and distance and so much. In this class, we will going to learn about the trigonometric function. The previous concept of trigonometric ratio will be generalized to trigonometric function. Okay. Firstly, we are going to know about the angle. What is angle? You have already known that. Angle is the measure of rotation of a ray about its initial point. Okay. So angle is the measure of rotation of a ray about its initial point. That means, suppose this is a ray. Okay. The initial point is O. Let this ray, namely OA, rotate anti-clockwise. That means this type, and this type means clockwise. Okay. So this rotate anti-clockwise, and the final position of this ray is OB. Okay. So this final position subtends an angle. This is the angle about 2 is initial position. Okay. This is the original ray. Okay. This original ray is called initial side. Okay. And the final position is called terminal side. Okay. And this point O is called vertex. Okay. There are two things we are going to know. Here just look. If a ray OA that is rotate anti-clockwise. Okay, and this is the terminal side, and this is the initial side. Okay, then the angle should be positive. Okay, angle should be positive. If a ray, that means OA ray, this is the initial side, and this ray is rotating clockwise, that means in this way, and the final position or terminal side is OB. Then the angle will be negative. Okay, this is clear. We have learned about the angle and the positive angle and negative angle. Okay, now we are going to learn about the measurement of angle. There are several units to measure an angle. Suppose we already know, if we measure a length, the units can be kilometer, meter, centimeter, millimeter, etc. Like this, angle measurement will be done by some units. Okay, here we are going to know about the units. Firstly, there are degree measure, and second is radian measure. Okay, by these two units we are going to measure angles. Okay, let's see. Suppose OA is a ray and it is rotating anti-clockwise. Okay, rotating anti-clockwise, and the final position of this ray after rotation is also the initial position. In the whole rotation called a revolution. Okay, this should be remembered. That means if a ray rotating from its initial point and come back again to its initial point, then the total rotation is called the revolution. Okay, if a ray OA complete one revolution, that anti-clockwise, okay, then the angle should be positive. Okay, and he will sustain an angle 360 degree. Okay, so a total revolution is equal to 360 degree. Okay, a revolution equal to 360 degree. Clear? A rotation from initial side to terminal side of a ray is 1/360 of its revolution is called 1 degree. Okay, that means the 360 divided by 360 we get 1 degree. Okay, a total revolution equal to 360 degree, then the 360 of 360 degree is equal to 1 degree. Okay, in this picture we have seen a total revolution cover 360 degree. Okay, so if the ray, this is the initial side of the ray and this is the terminal side of the ray, then and it rotating anti-clockwise, then the angle between the terminal side and initial side will be 90 degree. If head A, 0A, OA is the initial side and it rotating anti-clockwise and the terminal position is terminal side, that means in this position, then the angle between the initial side and terminal side will be 180 degree. Okay. If OA is the ray and this is the initial side and it rotating anti-clockwise and the terminal side in this position, that means OB, then the angle between initial side and terminal side will be 270 degree. Okay. We are going to know, we only get degree and there are two more concepts. Now look into this concept. We get 1 degree. Okay. If we divide 1 degree by 60, then every part will be 1 minute. That means 1 divided by 60 equal to 1 minute. Okay. If 1 degree divided by 60, then every part will be 1 minute. Okay. And if 1 minute will be divided by 60, then every part will be 1 second. Okay. This is the sign of minute and this is the sign of second. So 1 minute equal to 60 seconds. Okay. If we divide it by 60, this we will get 60 by 60. That means 1 second. So 1 degree equal to 60 minutes. Okay. 1 minute equal to 60 seconds. Okay. Therefore 60 minutes will be 60 into 60 seconds. That means 3600 seconds. This is the relation between degree, minute and second. Now we will know about the radian measure. This is. So first we are going to know what is the radian. If there is a circle with center O and this is a unit circle. Okay. Unit circle means the circle whose radius is 1 unit. Okay. That means radius is 1 unit. Okay. So if we draw a radius, that means OA, this is 1 unit. And let AP is a arc. Okay. With length 1 unit. Then the angle subtend at center by the arc is called 1 radian. Okay. So radian concept is just the 1 unit arc will subtend 1 radian angle at center of a unit circle. Okay. If here OA, just think OA is the ray and OP will be the ray. OA is the initial side and OP is the terminal side of the ray, and this is the AP is the arc. Okay. So the angle should be positive as this direction is anti-clockwise. Okay. If this is the OA initial side, okay, and this is the P, that means terminal side, and this is the arc AP of 1 unit. Okay, and it rotation clockwise. Then the angle will be -1 radian. Okay, this concept clear? This is a circle and this is a ray. This is the unit circle. Okay. We know circumference of a circle, unit circle is equal to 2 pi r. Here r equal to 1, that means 2 pi dot 1, that means 2 pi. Okay. So if this ray is rotating anti-clockwise and come again to its initial point, then the ray subtend an angle, that means 2 pi at its center. Okay, by a whole revolution. So a complete revolution of initial side of a ray subtend an angle 2 pi at center. Okay, we have seen in degree measure this 2 pi value was 360 degree. Okay, so here a complete revolution of a initial side of a ray subtend an angle, that means at center 2 pi radian. Okay, this should be remembered. Let a circle with radius r. Okay, and a arc AP, okay, with the length of L. Okay, and subtend an angle theta with the initial position. Then we have a formula. Which formula? Theta equal to L by R. Here theta should be in radian. Okay, so we have L equal to R theta, but L is the length of the arc. Okay, R is the radius of the center, radius of the circle, and theta is the angle in radian. Okay, by this theorem we have to solve many problems. Okay, so this formula is very, very important. We have seen that a circle subtend an angle to its center (2 pi radian), and in degree concept this is 360 degree. Okay, so we can write 2 pi radian equal to 360 degree. Okay, so by cancelling 2 in both sides, we have pi equal to 180 degree. Okay, pi radian. So 1 radian equal to 180 by pi. Okay, this is the formula to convert radian to degree. Radian to degree. Okay, and similarly we can write 360 degree equal to 2 pi, or 1 degree equal to 2 pi divided by 360 degree. Then cancelling 2, we get 180 degree, or 1 degree equal to pi by 180. So this is the formula of convert degree to radian. Okay. By this theorem, we will solve so many problems. Okay, let's now look at this question. Here the question number 1, convert 40 degree 20 minutes to radian. And second question, convert 6 radian to degree. So we have seen from degree to radian, we have 360 degree equal to 2 pi, or 1 degree equal to pi by 180. So here we have 40 degree 20 minute. Okay, that means first we have to convert the 20 minute to degree. To convert this 20 minute, we know 60 minute equal to 1 degree. So 20 minute will be the 20 by 60 degree. So 20 minute equal to 20 by 60. That means by cancelling this, we get 1/3 degree. Now I am going to doing here. So we get 40 degree and 1/3 degree. Now we get, that means 121 by 3 degree. Okay. Now we convert this degree to radian. We have 1 degree equal to pi by 180. So this degree into pi by 180. This is the value of radian. Now simplify this, we get 121 pi by 540 radian. Okay. Now the question number 2. Here given 6 radian. Okay. So we have to convert this to degree. So we have 1 radian equal to pi radian equal to 180 degree. So 1 radian equal to 180 by pi. 180 by pi. Therefore 6 radian equal to 6 into 180 by pi. Okay. We replace pi by 22 by 7. So we have 180 by 22 by 7. So by simplifying this, we get 180 into 7 by 22. Okay. Now cancelling 11, this will be 3. Okay. So we get 21 180 divided by 11. Just simplify this, you get the degree value. Okay. Now question number 3. Let's look at this question. Find the radius of the circle in which a central angle of 60 degree intersect an arc of length 37.4 semi. Use pi equal to 22 by 7. So here we are going to find the radius. We have seen the formula. L is equal to r theta. Theta will be the radian measure of the angle. So here theta equal to 60 degree. So we first convert this 60 degree to radian. So it will be 1 degree equal to pi by 180 degree. So 60 degree equal to pi by 180. Okay. This will be the radian. Here L equal to 37.4 semi. Let R equal to 8 semi. So we have L equal to r theta. Now putting this value, we get or 37.4 equal to x dot 60 x into 60 into pi by 180. Okay. Now cancelling this and this, we get 1 and this is 3. Okay. Or this can be written as 374 by 10 equal to x into pi by 3. Now here one thing, pi equal to 22 by 7. Now replacing this pi by this 22 by 7, we get here, or x equal to 374 by 10 into 3 by pi, or x equal to 374 by 10 7 by 22. Okay. So we have just cancelling these two, we get 2 here, 3, 4, 2, 17. So we have x equal to 17 into 21 divided by 10 semi. Okay. So we have to solve this. .7 semi. Okay. Just look at the question. The minute hand of watch is 1.5 seconds long, and how far does it move in 40 minutes? Okay. Here, minute hand in a watch. Suppose the watch is a circle, and minute hand is the radius of the circle. So 1.5 semi is the radius of the circle, and we know the minute hand complete one revolution, and it subtends 2 pi radian angle in center at center. Okay. So the minute hand in 60 minutes, the minute hand subtends 2 pi radian at center. So in 40 minutes, the minute hand subtends 2 pi into 40 by 60 radian at center. So by cancelling this, we get 2, 3, 4 pi by 3 radian. Okay. So this is the theta. Therefore, theta equal to 4 pi by 3 radian. We have r equal to 1.5 semi. So by the formula, we have L equal to r theta. So we have to find the L. So by putting this value in this equation, we get 1.5 into 4 pi by 3. By solving this, we can get 6 pi by 3. Okay. Now cancelling this, we get 2 pi equal to, now here pi equal to 3.14. Now replacing the pi by 3.14, we get 3.14. That means 6.287. Okay. Now look at this question. If the arcs of same length in two circles subtend angle 65 degree and 110 degree at the center, find the ratio of their radius. Okay. So let let L1 equal to length of the arc, length of the first arc. Okay. L2 equal to length of the second arc. Okay. R1 equal to radius of first circle. R2 equal to radius of second circle. Okay. Theta 1 equal to the subtended angle in first circle. Okay. And theta 2 equal to the subtended angle in second circle. So by theorem, we can write L1 equal to R1 theta 1. This is equation number 1, and L2 equal to R2 theta 2. This is equation number 2. By dividing these two, we get, by dividing these two equations, we get L1 by L2 equal to R1 theta 1 by R2 theta 2. Okay. Here says the arc are of same length. So L1 L2 equal. So the value of L1 by L2 will be 1, and R1 by R2 will be same, and theta 1 theta 2 equal to 65 degree and 110 degree. So we can write 65 and 110. But this is in degree. We have to convert this to radian. Okay. Degree to radian. That means pi by 180. By multiplication, this pi by 180. Okay. By cancelling, we cancelling we cancel both. We get or R1 by R2 equal to 110 by 65. By cancelling this, we get 22 by 30. So R1 is to R2 equal to 22 is to 30. Okay. Now we are going to solve the exercise number 3.1 of your NCERT textbook. Here find the radian measure, and there are 25 degree, minus 47, 30 minute, 240 and 520. So for the first we have to 25 degree. So to degree to radian we have to multiply this degree unit by pi by 180. So simply multiply this with by pi by 180. Okay. So we get, by cancelling this and this, 5 pi by 36. Now for the second, we have to convert this minute to degree. So we get minus 47 degree plus half degree, that means 30 by 60. So we get minus so minus 95 by 2 degree multiply by pi by 180. Just simplify this and get your radian value. Okay, these two is your homework. Okay, now for this, here this is the radian value, we have to convert to degree value. So simply multiply this with 180 by pi and replace the pi by 22 by 7. We get 11 by 16 into 180 by 180 into 7 by 22. Okay, so you get, cancelling this, okay, this will be the radian value. Second is your homework. Okay. Now for this, 5 pi by 3, just multiply this by 180 by 5. Now cancelling pi, okay, we get 300 radian, and this is your homework. Okay. Now question number 3. A wheel makes 360 revolution in 1 minute. Through how many radian does it turn in 1 second? So in 1 minute the revolution number is 360. Okay, and we know 1 revolution equal to 2 pi radian. Okay, so firstly we have to find in 1 second how many revolution is exists there. So 1 minute means 60 second. In 60 second, the number of revolution is 360. So in 1 second, the number of revolution is 360 by 60. By cancelling this, we get 6. Okay. So 1 revolution consists of 2 pi radian. So 6 revolution consists of how many radians? As 1 revolution consists 2 pi radian. So 6 revolution consists 2 pi into 6, that means 12 pi radian. Okay. Just look at this question. Find the degree measure of the angle subtended at center of a circle of 100 semi radius by an arc of length 22 semi. So we have seen, we know L equal to R theta. Here L equal to 22 semi. By putting this value, we get 22 equal to R equal to 100 dot theta. That means theta equal to 22 by 100. Okay, this is the radian value. So here we have to find the degree measure. So now convert this radian to degree. Now just simply multiply this with 180 by pi. Now replacing this pi by 22 by 7, 22 into 180 by 100 into 22 by 7. Then the 7 will be in upper position. 180 into 7 divided by 100 into 22. Now cancellation 22, 22 and 0, 0. We get 5, 10. Okay. That means 12.6 degree. Okay. Now look at this question. In a circle of dia 40 semi, the length of a chord is 20 semi. Find the length of the minor arc of the chord. This is silly tricky math. Okay. Problem. This is the circle. Okay. And this is the dia and this is the center of the circle. So dia is 40 semi. So radius is 40 by 2. That means 20 semi. Here a chord of 20 semi. Okay. So just draw a chord 20 semi. Okay. Just removing this. Let CD is the chord. Then the minor arc means CD. Okay. And the big portion is the major arc. Okay. So here the length of the chord is 20 semi. And if we draw a line from center, this is the radius, so this is also 20 semi. If we draw another line, we get this is also the radius, this is also 20 semi. Okay. So just look, COD is the triangle whose three sides are equal. So this is a equilateral triangle. So three angles will be same. So three angle will be the 60 degree. This is also 60 degree and this is also 60 degree. Okay. So here theta equal to 60 degree. Okay. So we now convert this to radian. Just multiply this with pi by 180. By cancellation this we get pi by 3 radian. Now okay. Let L is the length of the minor arc. Okay. So let L equal to length of the arc. So we know L is equal to r theta. By putting the value of theta and r, we get the length of the L. So r equal to 20 and theta equal to pi by 3. Then pi by 3 semi is the length of the arc. Okay. Now look at this question. If two circle arcs at same length, subtend angle 60 degree and 75 degree at the center. Find the ratio of their radius. Previously we have done this type of problem. So just L1 is equal to R1 theta 1, where L1 is the length first arc, R1 radius of first circle, theta 1, here theta 1. Theta 1 equal to the first angle. Okay. And L2 equal to R2 theta 2. L2 equal to length of second arc, R2 equal to radius of second circle, theta 2 second angle. Okay. By dividing these we get L1 by L2 is equal to R1 by R2 dot theta 1 by theta 2. L1 L2, as L1 L2 is same, so we get theta 2 by theta 1 equal to R1 by R2. Implies, now putting the value of theta 1 and theta 2 we get theta 2 equal to 75 and this is 60. As this value are in degree, so we have to convert this to radian. So convert this to radian, we have to multiply this with pi by 180. Then pi by 180 will be cancelled and there will be 5 and this is 4. 5 by 4. So ratio R1 is to R2 equal to 5 is to 4. Okay. Now question number 7. Find the angle in radian through which a pendulum swings of its length is 75 cm, and tip describes an arc length 10 semi. For the arc length 10 semi, what will be the angle? For 15 semi, what will be the angle? And for 21 semi, what will be the angle? We know L is equal to r theta. So therefore theta equal to L by r. So for the first, we put the value of L and r. Therefore theta equal to L by r. Here L is equal to the length of the arc, that means 10, and r equal to 75. Okay, so just calculate this. Cancellation this, we get 2 by 15 radian, and this will be the same. Theta equal to 15 by 75, 1/5, and this will be 21 by 75. Okay. Now we are going to learn about the trigonometric function. Okay. In previous class, we have learned about the trigonometric ratio of equiangle with respect to the right angle triangle. Okay. We now extend the trigonometric ratio in any circle in radian measure, and we will know them as trigonometric function. Okay. So first, extend the trigonometric ratio in radian measure, and we will learn them as trigonometric function. Okay. Let a unit circle with origin O and coordinate axis. Now we draw the circle. Okay. This is the center O. This is x axis. This is y dash. This is y. Okay. As it is a unit circle, so let a point here. Okay. Then the coordinate of A will be 1, 0. Okay. Let P be any point on the circle with coordinate A, B. Let P is here, and the coordinate will be AB. Okay. Just draw a perpendicular on OA, and the angle is X. Okay. Coordinate AB and angle AOP equal to X. Here, AP is the arc, so the length of the arc is X unit. So length of the arc is X unit. But we know A is equal to r theta. Here r equal to 1 and theta is equal to x, so L equal to x. Okay. Now we can define this triangle, just this triangle. Here let this is point Q. Okay. So POQ, from POQ triangle, right, this is a right angle triangle. Okay. Then we define cos x equal to base by hypotenuse. Okay. Base by hypotenuse. That means the base will be A, and hypotenuse will be 1. That means A. And sin is equal to perpendicular by hypotenuse. That means perpendicular equal to B, hypotenuse equal to 1. That means B. Okay. Now A square plus B square equal to 1, and sin square x plus cos square x equal to 1. Okay. Let this point will be B, this point will be C, and this point will be D. Okay. As complete evolution, subtend an angle 2 pi at center. Okay. So this angle will be pi by 2 as this is perpendicular. Okay, so as a complete revolution subtend 2 pi at center, therefore angle AOB equal to pi by 2. Okay, and when this came to OC, the angle will be from here to here, that means pi. Okay, and the total angle from here to here is equal to 3 pi by 2. Okay, so angle equal to 3 pi by 2. So here all these angles are integral multiple of pi by 2 are called quadrant angle. Okay, so this is the quadrantal angle. The coordinates of A equal to, we have seen 1, 0, and the coordinate of B will be 0, 1. Okay, 0, 1, and coordinate of C will be here. Here the value of x equal to -1, 0. So -1, 0, and D will be 0, -1, 0, -1. Okay. Quadrantal angle we have here for A mean the initial position. So the angle will be 0, cos 0 equal to 1, and sin 0 equal to 0. Okay. For the point B, the angle will be pi by 2. So cos pi by 2 equal to 0, and sin pi by 2 equal to 1. Then for C we have cos, here angle will be pi, so cos pi equal to -1, and sin pi equal to 0. Okay, and for the point D, cos 3 pi by 2, here the angle will be 3 pi by 2 equal to 0, and sin 3 pi by 2 equal to -1. Okay, and finally the ray came to 0A or OA. Then cos 2 pi equal to 1, and sin 2 pi equal to 0. So just look at this. Here, if I look the value of cos, value of cos is 1, and also when the angle is 2 pi, that means complete a total revolution, the value of cos will be same. And also for sin, the value of sin at the initial point 0, and after a total revolution, that means the total revolution means 2 pi radian, it rotates 2 pi radian, and the value will be 0. So the value of cos and sin is same when the angle increase or decrease by any integral multiple of 2 pi. Okay, so we can write this as cos 2 pi n plus x equal to cos x. Okay, when n belong to z, that means integer, and sin 2 pi n plus x equal to sin x when n belong to z, that means integer. These two formula is very important. Okay, further we will consider the value of sine as 0. Here when angle is 0, then sine, the value of sine is 0, and the angle is pi, then the value of sine is 0, and when angle is 2 pi, then the value of sine is 0. So we can write sin x equal to 0. Okay, if x equal to 0 plus minus pi plus minus 2 pi, okay, plus minus 3 pi, and dot dot dot. So this is the integral multiple of pi. Okay, and let's consider the value of cos x as 0. Okay, so cos x equal to 0. Here when the value of angle is pi by 2, cos x equal to 0, and 3 pi by 2, cos x equal to 0. Okay, so if x equal to plus minus pi by 2 plus minus 3 pi by 2, okay, plus minus 5 pi by 2, okay, and so much. So this is the, here x is not the integral multiple of pi by 2. This is the multiple, odd multiple of pi by 2. Okay, when x is odd multiple of pi by 2. Okay, so we can write sin x equal to 0 implies x equal to n pi when n belong to z. So n is the integer, and cos x equal to 0 implies that x is equal to, here just look, if n is a integer. Okay, so we can write this as n pi plus pi by 2. That means if we common pi by 2, we get 2n plus 1 when n belong to z. Okay, so this should be also remembered. We found sin x, cos x. Okay, so by this 2 we can find the reciprocal and the property. Cosec x equal to 1 by sin x. X not equal to n pi. Okay, as if sin x equal to 0, then cosec x will be not defined. Okay, so here n pi not equal to 0 and n belong to z. If we find the reciprocal of cos x, that means sec x equal to 1 by cos x when x not equal to this 2n plus 1 into pi by 2 when n belong to z. Okay, for tan x, that means sin x by cos x. Okay, when x not equal to, here cos x should not be 0, so x not equal to 2n plus 1 by pi by 2 when n belong to z. Similarly, by this we can find cot x equal to 1 by tan x equal to cos x by sin x. Here if sin x is 0, then cot x is not defined. Okay, so sin x cannot be 0. So when x not equal to n pi and n belong to z. Okay, this formula should be remembered. In previous class we have learned some formula. That means sin square x plus cos square x equal to 1, 1 plus tan square x equal to sec square x, 1 plus cosec square x, 1 plus cot square x equal to cosec square x. Okay, this formula also important. In previous class we have learned the values of trigonometric ratio of various angle like 0 degree, 30 degree, 60 degree, 45 degree and up to 90 degree. Okay, and the values are same for trigonometric function also. Okay, and here we will also learn some more values, that means 180 degree, 270 degree, 360 degree, and the values are just like that. Here 0, half, 1 by root 2, root 3 by 2 and 1. The value of cos will be reversed from left. So root 3 by 2, 1 by root 2, half, 0. Okay, and the value of tan will be 0. This will be 1 by root 3 and this will be 1 root 3 and this is infinity. Okay, that means not defined. Okay, now the sin 180 degree equal to 0, 270 mean minus 1 and 360 equal to 0. Okay, the value of cos 180 minus 1, 270 0. This is also minus, and by this we get 0 and this is not defined, that is infinity, and this is also 0. Okay, by this value the reciprocal of this sin cos at 10 we can easily get. Okay, now we will learn about the sign of trigonometric function. So in coordinate axis there are 4 quadrants: first quadrant, second quadrant, third quadrant, fourth quadrant, and here the sign of various trigonometric function will be different. Okay, so we will learn this. Here let O is the unit circle whose origin at the center, whose center is at the origin of coordinate axis. Okay, let unit circle whose center O is the origin of coordinate axis. Okay, let this is the point A and here P is the point whose coordinate is AB. Okay, let P AB a point on the circle. Okay, and subtend angle AOP equal to x. Okay, so let this is x. Okay, if the ray moving in anti-clockwise, if let here Q is the point. Okay, then the angle AOQ equal to minus x. That means this ray is rotating clockwise. So here the coordinate of P is a comma b. So here if we draw perpendicular, this line is measured B and this is also B, but here just look, from here this is A and there is in the y dash axis, so the coordinate of Q will be A minus B. Okay, so the coordinate of Q equal to A minus B. Okay, for these two we have seen here previously, we have seen that cos x equal to A for the point P. Okay, and this is 1, and for this we have cos minus x equal to A. By these two we get cos x equal to cos of minus x. Okay, and we have seen for this sin x equal to B and here sin x equal to minus B. So by these two we get, sin minus x is equal to minus b. We get sin of minus x equal to minus of sin x. Minus b means minus sin x. Okay. So this is number 4. Here these two equation is most important. Cos of minus x equal to cos x and sin of minus x equal to minus sin x. Okay. So now let's see the value of various trigonometric function in quadrant. Let's see, x dash, this is y and this is y dash. This is the first quadrant, this is the second quadrant, this is the third quadrant and this is the fourth quadrant. On the previous circle we have seen that for every point P, A comma B, we see that the value of A are between -1 to -1 and the value of B also lies between -1 lesser equal to B lesser equal to 1. That means -1 lesser equal to cos x lesser equal to 1 and -1 lesser equal to sin x lesser equal to 1 for all x. Okay. Here, if the ray rotating anticlockwise, let's suppose the ray is rotating anticlockwise, then the angle up to y is up to pi by 2. Okay, and this is up to pi, this is up to 3 pi by 2 and this is up to 2 pi. Okay, if a total revolution is complete, then the value of x here 0 to pi by 2 and here pi by 2 to pi and here pi to 3 pi by 2 and here 3 pi by 2 to 2 pi. Okay, so in the fourth quadrant the sign of the trigonometric function will be different. Here x dash, y dash. This is the origin. Here we should remember a mantra, that is all sin, tan, cos. Okay. The mantra is add sugar to coffee. Okay, please remember this mantra. Admin, in the first quadrant all of the trigonometric function will be positive. Okay, so add. Here in the second quadrant the sign and the reciprocal of sign, that means cosine, will be positive and rest will be negative. Okay, so for sign we write sugar, and in the third quadrant only tan and its reciprocal will be positive and rest will be negative. Okay, that means tan and quad will be positive. And in the fourth quadrant, so here we for tan we write 2 and here cos and its reciprocal, that is sec, will be positive and rest will be negative. So for cos we write coffee. So this mantra should be remembered and you can remember this as all sin tan cos. Okay, by a chart we can remember this. We have seen in the first quadrant all of the trigonometric function will be positive. So here all sin, cos, tan, cosec, sec and cot will be positive. In the second quadrant only sin and cosec will be positive. So only sin and cosec will be positive, rest are negative. In third quadrant tan and cot will be positive. So tan positive and cot will be positive, rest are negative. Okay. In the fourth quadrant cos and sec will be positive. So cos positive and sec will be positive, rest are negative. Okay. So by these two, we can remember the sign of the trigonometric function in fourth quadrant. Okay, that's all for today's class. And in next day, we will learn the domain and range of this trigonometric function, and we'll learn to draw the graph. And there are some formulas, and by this formula we can learn to solve problems and etc. Thanks for watching our video.